Okay, we are recording and we are back. So we're going to be going through 2022 June, Unit 1, question number 13. This is going to be part of your Moments playlist. And yeah, we're going to be doing this question. So let's get to it. So it says a cord is attached to a smooth door by a screw as shown. So this is the hook that you put your clothes on, and specifically this is a coat hook in this context. And then it says the diagram below shows 3 of the forces that act on the coat hook when a coat hook is hung from it. The weight of the coat hook may be neglected, and then they've given us a diagram. We'll come to that. And then it says add a labeled arrow to the diagram to show the additional force required for the coat hook to be in equilibrium. That's a strong and a really important word. To be in equilibrium. One of the major things I want you to look out for is when a system or something is in equilibrium, the net torque or moment will be equals to 0. So in this diagram above, it has to be in equilibrium. So the resultant force and the resultant moment should be equals to 0. So I'm going to do this in terms of moments. So if I take this point as the pivot, I can get rid of those other 2 forces, the vertical force from the screw and the horizontal force from the screw as well. So I can get rid of those because the line of action passes through the pivot. So this is my pivot. And I can see that I have a resultant moment, and that resultant moment is going to be in the anti-clockwise direction. So I need a force that has to be in the clockwise direction. And that force is actually going to be the reaction force from the wall. Now, when your coat hook is put with the screw, it's going to have a reaction force that's going to be coming from the wall in this direction. Reaction force from the wall. So that's the reaction force from the wall. Now, one of the major things that many students lost the mark was they identified, okay, there was going to be a reaction force. Many students, they did that. That was good. Thumbs up. The problem that gets them in trouble is where do we put the reaction force? Now you will think, sir, this is 2 marks. It shouldn't matter. It does matter. Because if you put the reaction force here, the moment will be clockwise. The moment due to the reaction force will be clockwise. And if you put the reaction force right over here, the moment will actually be anti-clockwise. If you put it here, it's going to be clockwise. If you put it here, it's going to be anti-clockwise. So what we're looking for is something that's going to oppose the moment due to weight. Now the weight is anti-clockwise, so we need a force that causes a clockwise moment. So we're going to put it right over here, because in this area, the reaction force will cause a clockwise moment, and in this area it will cause an anti-clockwise moment. And we're looking for a force that causes clockwise, so it should be right over here, below the pivot point. So you can think of it like this as well. I've drawn a bit of a better diagram to help you understand. So this is going to be below the pivot, so this area, and this is going to be above the pivot. Above the pivot. Now you can notice here, this is going to cause a anti-clockwise moment, and it's going to cause a clockwise moment. That's clear. And that's what we want for equilibrium. But if I move this here, you can notice that this will cause an anti-clockwise moment. You can see that? That's the problem. And that's why examiner did not award the marks for students who put the reaction force above the pivot or even on the pivot point. Putting it on the pivot point is just completely wrong. Do not put it on the pivot point, because your force then becomes, the moment due to the force then is just 0. So again, you would not be in equilibrium. So do not put it anywhere here. Put it below. So be careful with that. The keyword, strong emphasis on equilibrium. Okay, so a student of mine struggled with this question, so I explained this a bit more in detail. And yeah, now next part is actually not that hard. So let's look at here. Okay. I wanted to add one more thing to this part as well. There's one thing I missed. This reaction force comes because of the contact with the wall and the coat hook. So when I was doing the other question, I realized this. I missed this point in the examiner report. The examiner specifically said, and even the mark scheme it says this, if you draw your reaction force here, you're not going to get the mark because there is no reaction force here. The reaction force comes because of the contact between the coat hook and the wall. Okay, that's an important thing as well. So keep that in mind. Okay. So, anyways, let's come back to this part. If too many quotes are hung on the coat hook, the hook will rotate and pull the screw out of the roll. Point P is the position of the pivot as shown. Okay, and the maximum horizontal force from the screw is 150 Newton. So, okay, 150 Newtons. And then deduce whether a person could, and then they've given the mass of the one quote, which is going to be 2.6 kg, and whether a person could hang more than 2 of these quotes. Alright, now first thing, why do we ignore the vertical force and why no values of vertical force has been given is because the line of action of vertical force passes through the pivot, so it's going to have a moment of 0. Secondly, we can look at two forces, the weight. So we're going to see the maximum weight that our screw can take in while it's at equilibrium. And then it's going to have a distance from the pivot as 2.5. And I'm not going to convert it to meters because I can just take the other distance as centimeters as well. So this is going to be my anti-clockwise moment, and this is going to be my clockwise moment. So they're going to be balanced, and that's when you want to find the W max then. So we're going to have 0.9 then, and we're going to have 150. So let's quickly just find that out. So my maximum weight that the coat hook can take will be 54 newtons. We can divide that by 9.81, and that would give me 9.81. That will give me 5.5 kg, and we'll divide by 2.6 kg. Let's divide that by 2.6, and we should get 2.11 kg, or not 2.1 kg, 2.2 quotes. Basically 2 quotes. So basically 2 quotes. So you cannot hang more than 2 quotes. Not hang more than 2 quotes. Okay, so that's going to be the answer for this question. I think the first part, which is just 2 marks, is much more tricky to do. And yeah, that's all.